Good morning, everyone. This is Jim, and I'm going to show you a bit of the workflow that I figured out to use the PVG assets inside the Godot engine. So, quick summary of what we're going to do is to create an animation player that uses a PVG small animal asset and creates an animation for everything that those things can do in all four cardinal directions and the diagonal directions as well. So, the PVG assets are just images, so they can be used in any engine that you want. However, you do need to map the individual frames to some sort of logical representation of what the animation is. So, like I mentioned, there's a lot of assets and there's a lot of animations in each asset, and it can be tedious to set up an animation player for every single one of those things. And it can be even more tedious to create blend spaces in some kind of animation tree state machine for all of those as well. So I have two things that I'm going to show you to cut down on the repetitiveness of making all those things. And the whole idea here is I just generate scene files outside of Godot and bring those into Godot so that you don't have to manually do things over and over and over again. So the example I'm going to show, like I said, is with a small animal player, and I'm going to use the newly released chicken asset, and I'm going to make the chicken cross the road. So to do that, we're going to start with a road and a chicken object. And the idea is that we'll plop a chicken on our screen and then give him the ability to idle, walk across the road, and then I'll put a quick little attack animation in. It won't be hooked up to anything. This is just to show how to play the animations, and you can do whatever you need to do to make those work within your game. So I've cheated a little bit and started out. I have a road scene here, and I also even have a chicken object that I've created. This chicken is a kinematic body. There's no visible representation of it yet, and there's a small bit of code associated with it. This code that we're starting with really doesn't do much. It's essentially just the modification of some copy-paste code from the Godot website for click and move. And the game I'm working on, it's called A Journey to Nowhere. It's a ranger-based game, and it's very heavily influenced by Ultima Online. So we're going to do Ultima Online movement for this demo. So that'll be right-click, and then the character will follow the mouse. One thing I want to point out is that I've created two inputs. One called mouse walk that responds to a mouse, the right mouse button, and one called attack, which will happen whenever I press number 1. So you'll see those whenever we get into it. Okay, so the first thing we need to do is add some images to our chicken that represent the different frames of animation. So I'm going to add a new sprite, and then I'm going to pull my chicken object into my project. There it is. Where it is. Where'd you go, sprite 1? There we go, sprite 1. So I select my sprite, take my image, pop it into texture. Now we have every single frame that we could ever imagine for the chicken. I'm going to go to the animation section of the sprite and set the horizontal and vertical frame count to 20 apiece because I happen to know that's what it is. I also don't want to... Now I guess I do want to have that centered. No, I don't want to have that centered. Okay, so now we have our chicken on the map. I'm going to move it just to the edge here. There we go. So if I play this, the code that I have in place right now to handle the movement should be enough to get him to take a walk. So I'm right clicking. There we go. The chicken is moving across the screen, following me. He crossed the road. That's great. But we want an animation. That's the whole point of this video. So let's do that real quickly. So the first thing I'm going to do is bring in an animation player to my chicken kinematic body object. So I've generated an animation player called Monster Small Player. And what this is if you look at the actual code, is a scene file that contains all of the animations, all the animation names and frames from the small monster set that comes with the PVG assets. So if we look at the file, what we're looking at right now is a file that shows essentially a spreadsheet representation of what Jesse from PVG Games PV Games includes in his guides. So this tells us where the frames are for running and walking and everything else for the small monster sheet. This is a spreadsheet representation. This spreadsheet gets fed into a PHP script that I wrote because I knew PHP whenever we started this, and it generates that small animation file. One thing I want to point out is for more complicated animations, there are multiple sheets, and so we have to deal with that. And the script knows that we can give the scripts a reference point of what file or sprite any given animation is in. So that's not useful for the small monster player. We'll talk about that in a future video, but I just want to be aware that we can switch sprite sheets. So the first thing to note here, though, is that it's expecting a sprite called AnimAll. So I am going to need to rename my sprite to AnimAll. Okay, so let's fire open this monster small player scene, which represents our, I'm going to give this a quick close, because sometimes whenever you're bringing things in externally, Godot tends to not like it. So we'll just let it get all caught up with itself. There we go. This looks a little better. So I'm on my scene, and I'm going to bring my animation player into the chicken. Now I have a small animation player, and if we look here, if you saw quickly, it's on the attack 1 east animation, and it did indeed animate. So what this animation player has is an animation representation of each direction per animation. So we can see attack 1 east, north, etc., and one for all of these things. So that's what the script did for me and what it can do for you. You don't have to set all these up manually. So if we can see there, he's walking. So that's great. If that's all you need, if you just need to figure out how to get the animation in place, that's how you do it. You bring in the small player, and then you create an animation in the same node. You create a sprite in the same node named AnimAll, and that corresponds to these frames down here. And then that's it. However, if you'd like to stick around a little bit, I can show you how to use these animations in a little more meaningful way with Godot's animation tree. So to do that, I'm going to create a new animation tree. And by the way, if you don't know how these animation player and animation trees work together, check out Heartbeast's Action RPG tutorial where he talks about everything I'm showing you and how to use the animation tree. But the gist of it is that we're going to make an animation tree, not an animation tree player, an animation tree. And we're going to use this as an animation state machine and add 2D blend spaces so that we can take the directional vector that our kinematic body, in our case the chicken, is moving, plug that into the blend space, and that will figure out for us which direction to render. So what we're going to do is we're going to have an idle animation and a walk animation placed in our state. So those will be two of the states in our state tree. And then each one of those will actually be a 2D blend space so that we can say if I'm walking towards 1, 1, for example, well, what's 1 map to? It maps to southeast. And then it'll play the southeast version of the chicken's walk animation. So I've created my animation tree. I'm going to make it a 2D blend space. Or I'm sorry, I'm going to make it a state machine. I'm going to assign it to our small monster player animation. So great, here we are. Right now we have our animation tree. Another little cheater thing I'm going to do is instead of creating a new 2D blend space and drawing all the triangles by hand and adding the animations in, I'm going to cheat because I've generated all these as well. another part of my script generates 2D blend spaces that represent all of the actions that you might want to have. So instead of creating the new 2D blend space, I'm just going to load these 2D blend spaces, which I've already put in here. I'm going to load one for idle. I do need to rename it. And now when we look at this, we'll see that I already have all these points in place. And they do correspond with the idle animations. So that's great. Now we have something that will, if nothing else, that can at least let us handle our animation states. So very quickly, I'm going to hack some code into our chicken object. I'm going to get access to my animation tree. And then I need to get, that's not right. There we go. And then I need to get access to the animation tree's state, which is what's going to let me travel to the different states and therefore play the animations. And this is still pretty janky because you have to get these string-based parameters, which nobody likes to do, but as far as I know, there's no better way to do it yet. Whenever we fire up our script, we need to make our tree active so that it plays. And we're going to come into here and just say that anytime we're not moving, we'll be idling. This is in the physics process here. So what we should see whenever we run this is our chicken idling a little bit. And we don't. Let's see, why not? Let's see, we're running. We didn't autoplay our animation. That should do it. And now when we run this, we can look and see that we're idling ever so slightly there. So that's great. One thing to notice is that we were facing left even though we should be facing right. And so even if I move around, he's not changing direction. We do want him to change direction. So what we're going to do is anytime we move, we're going to set his blend space or his blend position so that whenever it goes into the 2D blend space on the animation tree, it plays the right one, or it uses the right direction. It's blend position. And we want to set that to our vector, our velocity vector. And we also want to normalize it. Because if we don't normalize it, then we're outside of the bounds of what the blend space is expecting. And what that actually ends up doing is that it never hits it on one of the cardinal directions. It only hits it on a diagonal. So let's just make sure that our chicken, oh, we got an error. What did I do? Normalized, not normalize, right? Normalized, yeah. Okay, so now our chicken is facing the right direction. We want to make him walk really quickly. To do that, we need to have him walk. So tell him to travel to the walk state, and then we need to set the walk animation. Of course, we don't have a walk animation, so let's do that. We're going to go back to our animation tree really quickly. I'm going to load in our walk blend space that I made prior to this, that you can just download out of the YouTube tutorials, or out of the GitHub link that's in the description of this tutorial. So I'm going to make it so that I can travel from my idle state to my walk state, and then back to my idle state. That's great. And you know what? While I'm in here, I told you we're going to do a walk, and we're also going to do a quick attack one as well. So idle, I can go from idle to, this will be my attack one. And then something I want to do whenever I do the transition back from attack to idle, I want to make it play the whole animation. So don't transition back until I've finished the attack animation. That's what that little line there does. So attack. All right, so I'm walking. I don't have anything for attack yet, or idling. I think this should work. Okay, so he's walking when I want him to idle, and he's idling when I want him to walk. That's funny. Oh, because I put this in the wrong place. So what we really wanted here was if I'm not where I'm going yet, then travel to walk. If I am where I'm going, then idle. Travel to idle. All right, so the chicken is idling. Now he's walking, and he's walking across the road. And then just very quickly, just so you can see the power of this, because remember that we've only shown 2 of the several animations here. So let's just see how quickly it is to add another animation. In this case, I'm just going to do the attack animation. And if I'm attacking, I can do AnimationState, travel to attack. So notice the stuff you didn't have to do. You didn't have to create all these animations by hand and map all the frames. You didn't have to create all the blend spaces, and all you had to do was a little bit of boilerplate to set the animation up and then create the animation tree yourself, which you probably want to do anyway, in case you ever want to string animations together, like put 2 attacks on top, one after another, or anything else. I've found that each one of my creatures or characters normally wants its own animation tree, and as long as I can set those up fairly quickly, it's not too bad. So I'm not attacking. Why am I not attacking? Because I spelled that wrong. Oh, and one more thing that we need to do is we always have to set the blend position for all of our states. And we do that when we're moving, so when mouse walk is pressed. What I had to do here, just so you know, is this corresponds not to the attack state in my animation tree, but the UI configuration I did at the beginning of the video, where I configured the attack button, and that's the one I mapped to 1. So now I should be able to press 1 and attack. Oh, look at that. He's not attacking in the right direction. He's always attacking east. Why is he doing that? Travel state attack. I am setting my blend position. Curious. Blend space is set okay. I'll bet I just didn't save it. Yep, there we go. So why did the chicken cross the road? To play an attack animation. There we go. So stay tuned for more videos. I'm going to do the large monster player next, which requires multiple sprite sheets. And then after that, I'll do a video about using the actual characters, which is significantly more complicated because there are tons of sprites, and that's, for my own workflow, I use Martin's RPG tool software to generate some composited set of images and then bring them into Godot. So that can get a little complicated. Stay tuned. Let me know if you have any questions, and thank you very much for watching.